Okay, here in topic 5, we're going to actually talk about solving those quadratic equations. And I want to remind you we have 4 methods to find what we actually use 4 different names as finding the solutions. So solutions again are the x-intercept, or where they cross the x-axis, and they have lots of names. The x-intercept, zeros, roots, solutions. So we have 4 names and we have 4 methods to solve a quadratic equation. So to get started, I think what we'll do here is for the first, let's say 4 problems, 36, 37, 38, and 39, we are going to use a factoring method. So I'm going to have you go ahead, pause, try those out, and come back and take a look. All right, so for number 36, using factoring, there's a GCF, and x will come out, and that will leave us with x times x plus 8. Now again, remember, they're all set equal to 0, so we're going to set each factor equal to 0, or we're going to tee it up, and that'll leave me with x equals 0, and then it would also leave me with x plus 8 equals 0. Now I would subtract 8 from both sides, and I would have x equals negative 8, so my solution set would be x equals negative 8 and 0. Now 37, the first thing you had to do was make sure you got it equal to 0. So the negative, or the 10x had to become negative and switch over to the other side. We're going to subtract it from both sides. You're going to take out your GCF, and then you can set it equal to 0 and tee up both sides. Number 38 also had a GCF. And with that, after we got the 2 out, we still had x squared minus 36. Well, that is a binomial, and I'm looking at that, and I'm like, difference of squares. So that was x minus 6 and x plus 6. You had to tee up all of your factors, and again, 2 doesn't equal zeros here, so we just kind of cross that off. We'd add the 6 over, so x equals 6. We'd subtract the 6 over, so it would be x equals negative 6. So my solution set would be negative 6. And then in 39, the key point here was the first step was, again, it has to be equal to 0. So I'd subtract the 6. What I do to one side, I do to the other. And then I would see that I have 4x squared minus 49. Again, that's the difference of squares. The square root of 4 is 2, and the square root of 49 is 7. So we would set those up, set them both equal to 0, solve for x, and our solution set would be negative 7/2 and positive 7/2. So let's go ahead and take a look at the next ones. I've got 40 and 41 here. And I hope that when you're reading those two, you notice something very unique about them. Yeah, I'm hoping you're noticing that I have an x squared and a constant here. So for both of these, I'm actually just going to use the square root method. Remember what I just had you use factoring. Now we're going to use the square root method. So to do so, we're going to just solve this across. So I'm going to go ahead and give myself some balance. I'm going to add the 30 to both sides. So I would have 1/2 x squared equals 40. Okay, and then we're going to go ahead and I have to undo this 1/2. So if it's been multiplied by 1/2, the reciprocal or the multiplicative inverse would be 2. So we'll multiply both sides by 2. So now I would have x squared equals 80. Now x squared equals 80, I'm going to go and take the square root of both sides, and x would equal, well, I don't know what the square root of 80 is. Let me get my calculator out here. The square root of 80 is, it looks like 8.94. We're just going to go ahead and round. So this would be positive or negative. Don't forget that when we take the square root as mathematicians, it's positive and negative. 8.94. So if I was writing it as a solution set, I might say x equals negative 8.94, comma, positive 8.94. So that's using my square root method. 41, let's try the square root method. So I'm going to subtract 9 from both sides. Remember, keeping in balance. So I would have negative x squared equals 8. Now I need to divide both sides by -1. So I would have x squared equals -8. And I would go ahead and take the square root of both sides. And I would know that that negative there tells me that my solution would actually, for now, be no real solutions. There's no real solution. I cannot find two numbers that would multiply by themselves. So a negative times a negative would make it a positive, and a positive times a positive is a positive. So there's nothing that's going to multiply to make -8. So that's using your square root factor. Let's see. Let's take a look at the next set. Okay, 42 and 43. Those just look like trinomials. So let's go ahead and use a trinomial factoring. So I'm going to move the 6 over. So 6x. Remember, 5x. I'm going to move the 6 over. So -6 equals 0. Yeah, I can just factor that. What multiplies to -6 and adds to 5? Well, that would be, let's see, -6, no, +6 and -1, right? Then I could tee both of those up and set them equal to 0. So x plus 6 equals 0. I'd move the 6 over by subtracting it, so x equals -6. And then x minus 1 equals 0. We'd move the 1 over by adding it, so x would equal 1. So my solution set here would be -6, 1. Okay, so 43. I got x squared equals. Now, it seems like the x squared would go over and make it easier, but I want to keep it positive, so I'm actually going to move everybody else over to the x squared. So I'm going to say, well, x squared, I'm subtracting the 18x to the other side, and I'm adding 81. I'm going across the equal sign. I'm looking for numbers that multiply to 81 and add to -18. And I do believe that that's going to be x equal -9 and x minus 9 again. So those are both going to be negative. We tee them both up. We realize they're both the same. So x minus 9 equals 0. X minus 9 equals 0. Therefore, my solution to 43 is x equals 9. Okay, that was factoring using basic trinomials. We want to use all of our methods. So I want to look at 44 and 45. Let's use the completing the square. So completing the square is the only one where I actually don't want it equal to 0. We're actually going to move the 14 to the other side. So let's go ahead and add the 14 over. No, I'm going to go ahead and write what we're doing here. This is completing the square. So x squared minus 4x, I'm going to leave a hole, because remember that's where I'm going to put the part that fills in the square, equals 14. Now, I need half of this -4, so -4 divided by 2 equals -2, but I'm going to square that. So -2 squared is 4. So I'm going to add 4 here. I'll tell you what, I'm going to show you using different color. I'm going to add 4 here. And what I do to one side, I have to do to the other. So when I write this, I'm actually going to write it as if though I'm breaking down this trinomial. And so I'm going to say, well, that means that I'm actually have x minus 2 squared, and it's all going to equal 18. I'm going to take the square root of both sides, which would leave me with x minus 2 on this side, because the square root undoes the square, equals, and then I need to know plus or minus the square root of 18, which I don't know what that is yet. We'll have to figure that out. What is the square root of 18? Well, square root of 18 looks like about 4.24. So we'll just use decimals for today. Let's go 4.24. Now we're going to have to add the 2 over. So x equals 2 plus 4.24 and 2 minus 4.24. So I know that the first one is going to be 6 and 24/100ths. And then 2 minus 4 and 24/100ths leaves me with -2 and 24/100ths. So I'm going to go ahead and say, well, that's my solution set. So that's completing the square. I tell you what, let's do that again. Let's go ahead and try that for number 45. Ooh, the 37's already over there. But when I look, oh, the negative x squared. Let's go ahead and just divide everybody by a negative because we need the x to be alone. So x squared plus 14x, I'm going to leave a hole, equals negative 37. Again, I just divided everybody by -1 so that the x squared was positive. Now I'm going to come over to the side. 14 divided by 2 is 7, but I actually need that squared, so that's 49. So let's put that in. I'm going to add 49 to both sides. And then we're going to rewrite this. So this will be x plus 7 squared. We did that on purpose. 7 times 7 makes 49, and 7 plus 7 makes 14. We wanted that. Negative 37 plus 49 is 12. Now we're going to go ahead and take the square root of both sides. And so I would have x plus 7 here equals plus or minus, what is the square root of 12? Let's see here. 3.46. So let's do this, 3.46. We're going to subtract the 7 from both sides. So now I have negative 7 plus 3.46, and I'm going to go and divide this up. And I also need negative 7 minus 3.46. Those are different. So when I take negative 7 and I add 3.46, I have negative 3.54. And negative 7 minus 3.46 is going to be negative 10.46. So let's go ahead and say, well, my solution set is, remember I list these from least to greatest. And there's our solution set. Okay. 46 and 47. These are trinomials that I need to set back up. I'm going to go ahead and move everything over to set it equal to 0. So I'm going to have 3x squared plus 9x minus 30 equals 0. We're going to factor. Let's go and take a 3 out. So x squared plus 3x minus 10. Trinomial with a 1 as a coefficient, so let's go ahead and break it down. So x and x, what multiplies to 10? And we'll add 2, 3. I'm thinking, how about plus 5 and negative 2? We're going to set each of those factors equal to 0. So 3 equals 0, x plus 5 equals 0, and x minus 2 equals 0. Well, of course, 3 does not equal 0, so that's not an option. But if I go ahead and I move the 5 over by subtracting, this would be x equals negative 5. If I move the 2 over by adding it, this would be x equals 2. So my solution set is negative 5, positive 2. And then I have my next one. Again, I'm going to try to get a GCF out, right? But I notice right off the bat I cannot get a GCF out. And so since I can't, this is where I'm going to change a trinomial into a polynomial. So this would be 12. So let's rewrite that. 6x squared. I need something that multiplies to get to 12. That will get to negative here. So I'm thinking, how about negative 4x and positive 3x? If I put negative 4 and 3 together, yep, that'll work. We're going to go ahead and group the first two terms and the last two terms. So when I take that out, GCF, we're going to take out a 2x, which will leave us with 3x minus 2. Here, I already have 3x minus 2, so we're just going to take a positive 1 out so that I can put my GCFs together. We'll rewrite. I have 2x plus 1, and I have 3x minus 2. We're going to go ahead and tee that up, Remember, we're looking for solutions. We're not just multiplying. We're actually looking to get a solution here. So 2x plus 1 equals 0, and 3x minus 2 equals 0. These are just two-step equations. You'd subtract the 1 over, so you'd have 2x equals negative 1. Divide by 2, so x would equal negative 1/2. Here, add the 2 over, 3x equals 2. Divide by 3, x equals 2/3. And we'll just go ahead and leave them just like that. We're okay with that today. So x equals negative 1/2 and positive 3/2. So far we've used factoring, difference of squares. We have used the square root method. We have factored trinomials 2 different ways, and we've used completing the square. So there's only one method left, and that is setting up that quadratic formula. So I want you to, first off, remember what the quadratic formula is. So that is where x equals negative b plus or minus the square root of b squared minus 4 times ac all over 2 times a. So go ahead, pause, set these two up. They're going to take a little longer. Do remember they both have to be equal to 0. So while 48's already ready, you're going to have to do a little work on 49 to get the 5 over. And get those set up and then come back. All right, so 48 and 49 have been worked out. And I just want to type those up for you and put them into the calculator and round into the nearest hundredth. So it's important to remember that when you're doing that and you're typing them in, for instance, like for where I had negative 8 plus the square root of 88, I put in negative 8 plus the square root of 88 equals, and then I divided that by 4. So make sure you get those typed up properly. So again, we have 4 different ways to find solutions: factoring, square root method, completing the square, and the quadratic formula. And we just looked at all 4 of those.